Name of the project Apple MAV. Greetings everyone. My name is Aditya Shiras of Aether Initiatives in Viksit Bharat. I will be speaking more about the April MAV's theoretical part. The aerodynamical part will be spoken by Maklesh K. And furthermore details by Vishal. The government has been started spending more amount of money for the space research centers for education and research purposes. Well, we consider that our project is a major milestone for this whole project. The whole country has been spending more money in the space sector. Well, we have found a solution for that. It's reliable, it's feasible, and it's sustainable. We can reuse the same engines and its parts one again and again until it's worn out. It raises the India's economic and sustainable development highly. The sustainable development goals, which I'm coming on to, the whole country, every country has been signed for the SDGs to be completed by 2030, and we are just near from the deadline. Especially in the SDG 7, 9, and 12, which our project can variably has a potential to complete it. Our project plays a major milestone for our development of sustainable development and in the space sector, especially. Furthermore, I'd like to give it to Maklesh K and the bit.
Salutations to the viewers. I am Mahilesh from S&P. So, I'm going to talk about the outer body of the rocket. Also known as the airframe, is what gives to rockets its shapes and protects everything inside. It has to be strong, lightweight, and able to handle a lot of heat and pressure when the rocket blasts off. So initially, we are just planning to prepare the rocket body with the materials like stainless steel and zirconium dioxide coating for a better insulation interinsulation. The rocket body has different parts. The nose cone at the top helps reduce air resistance, and the payload fairing protects the satellite or the cargo. The main body is designed in a way that it holds the most fuel. At the outside of the rocket is carefully designed to be have a smooth airflow and so that a less air drag can contribute for a better flow and understanding. Now I am passing the idea to the Vishwajit.
So I'm Vishwajit and I'm going to be explaining about the technical parts of the rocket. So in the technical parts of the rocket I'm going to be telling about the engine and our software and how it's going to work. So for the engine it's a liquid fuel engine which runs on 85% concentrated nitric acid and it's used as an oxidizer and as a fuel we are using turpentine which is basically C10H16 as its chemical formula. Now the engine is an expander cycle engine and it's designed, developed and done everything by ourselves. So as of now, the recording of the video, we have only done the simulations of the engine, but we are very sure that we can complete the engine and get a flight test ready hardware soon. So for the rocket, the we are going to be using an AI powered camera recognition system which can land on any terrain. Say there's uneven terrain which anything hasn't mapped, like for example, a satellite hasn't mapped. So this video feed on the rocket will be sent to the microcontroller and it will look at the terrain and it will spot any anomalies and the onboard ultrasonic sensor and LiDAR sensor will point towards there and check the height and adjust the landing legs accordingly. And speaking of the landing legs and uh, the height distance from the ground will also be taken care of by LiDAR and the ultrasonic sensors. And for test flight to know where the rocket is, instead of using GPS, we're going to be using laser guided systems, such as like there will be sensors on the rocket and lasers will be guiding it. Now I'm gonna be showing you about simulations. So before that, let me show you about our model. So for our model, this is what we've done according to calculations and some other technical aspects. So our model basically looks like this, and if you go to the other side, you can see the cross section of the model. So here we have interval cooling channels which ensure the rocket does not melt, and over here you can see the injector which is a swirl injector. And next I'm gonna be showing you the simulation results. So this was run on ANSYS. It's a simulation software used by professionals and I have personally learned this. So this is ANSYS Fluent to be exact, and this is the pressure wave for the engine. So according to physics, the pressure should drop after it reaches the nozzle throat, and it should be higher towards the combustion area. So over here we can see that the combustion area is higher from this graph over here, and as it goes through, it increases towards the throat, and then once it reaches the throat, it suddenly changes. You can see as it swiftly smooths out, and it slowly turns into a lighter and lighter color, so which means the pressure is dropping and the velocity is accelerating. The exit velocity is Mach 4 times the speed of sound. So that's it for our project here. So thank you.